I work in a lab called Intellectual Ventures, and we invent stuff. I'm going to talk a little bit about that, but I'm also going to start by trying to make a couple of interesting points, I think, about hackers. So this is a hotel room, kind of like the one I'm staying in. Pretty boring place to hang out, except that TV is not like the TV in your home. That TV is a node on a network. It's connected to all the other TVs in the hotel. And with a little USB infrared transceiver hooked up to my computer, I can start sending codes to the TV that it's not expecting. Codes that the remote in the room can't send. And that means I can watch movies for free, which isn't all that exciting, I know, don't worry about that. I can play games for free. But I can not only do that for my TV in my hotel room, I can do that for your TV in your hotel room. I get to decide if you're watching Disney or porn tonight. If there's a checkout system on there and you're putting your credit card number in, I can watch you do that. If there's a keyboard hooked up so you can surf the web, I can watch you surf the web. I don't know if you guys can even see these slides. These are just screenshots of hotel TVs we've taken. I like this one. Funds transfer. That's like $13 million funds transfer. This is people just surfing the web. You never know what they're going to do in their hotel room. Back in when Wi-Fi was first getting popular, we were trying to show security problems with Wi-Fi. And we built a tool called AirSnort to crack Wi-Fi encryption. And one of the things we did is we built this robot called the HackerBot, which could drive around and find Wi-Fi users and show them their passwords on the screen, which we thought was fun. And one of the things we learned from that was that doing the same thing with a laptop wasn't very mediagenic, and so it was hard to get much attention for these problems. And the HackerBot was very exciting and friendly, and people put it on television because it was funny. And so we made the pistol version of the same thing. And for your long-range password sniffing action, we built all kinds of crazy things. Another project we did to try and show unintended security implications was at a conference called the Computers, Freedom, and Privacy Conference. Ben Laurie and I put a computer in each room of the conference that would just log all the Bluetooth traffic. So whenever anybody was wandering around, their phone or their laptop that had Bluetooth, we'd log that, put it in a database, and then we could print out a map like this for each person at the conference. So at the Computers, Freedom, and Privacy Conference, where they talk about these kind of issues, this is the map for Kim Cameron. He's the chief privacy architect at Microsoft. Unbeknownst to him, I know which sessions he went to, when he got bored, went downstairs. I can correlate this with other people at the conference and show who he hangs out with. And we could do the same thing with GSM or with RFIDs and your passports and things. This is a buddy of ours named Sammy, who was a MySpace user. Anybody here ever used MySpace? Okay, well, it's kind of like Facebook for your grandparents. Sammy was trying to meet chicks on MySpace and figured out that the only way that's going to work is if you have some friends on MySpace, you seem not too creepy. But if you don't have any friends, you're a total loser. And Sammy didn't have any friends. So he wrote a little bit of code that he put on his page on MySpace so that whenever you look at his page, it would just automatically add you as his friend and skip the whole "is Sammy really your friend" protocol. And then it would copy that code onto your page and change your page to say that Sammy is my hero. But because that code was on your page, whenever anybody looked at your page, it would automatically add them as Sammy's friend too. So in under 24 hours, Sammy had over 1 million friends on MySpace, and he's just recently finished serving 3 years probation for that. I think MySpace should have hired him. Maybe they'd still be around. Even better, another buddy of ours, Christopher Abad, was trying to figure out how to meet chicks on MySpace, but having spotty results. So he took profiles of girls he dated and liked, and fed them into a spam filter as legitimate email, profiles from girls he dated and did not like, and fed them into as spam to train the artificial intelligence in the spam filter so that he could run it against every profile on MySpace and outspits girls you might like to date. So, you know, if there's anybody here who hasn't decided what kind of web company you want, I think there's like 3 startups here. We can have spam dating instead of Match.com or whatever, right? The reason I'm telling you all these stories is that the way these guys think is really, really important, right? Hackers look at the world in a different way. An example I use is if you get a new gadget and show it to your mom, she might ask you, well, what does this do? And you would explain, Mom, it's a phone. Oh, I got it, it's a phone. That makes sense to someone. For a hacker, the question is different. The question is, what can I make this do? And I'm going to take all the screws out and tear off the back and break it into a lot of little pieces, but then I'm going to figure out what we can build from the rubble. That discovery process of figuring out what's possible with every new technology, with every new bit of science, with every new invention is fundamental to invention. It's fundamental to innovation. That's the first step. And if we skip that step, then we're going to go build businesses out of dumb ideas, right? So the first step is discovering what's possible. These guys are optimized for discovering what's possible. They're violating the warranty before they even get something out of the package, right? And that mindset that hackers have is really fundamental, and we need to get them out of security and back into product development, and I'm hoping that's what you guys will be good for. Anybody use these keys to get into your car? Bloop. Yeah. Kids will drive through a Walmart parking lot these days, clicking open, 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 bloop. Eventually, you find another car kind of like yours, maybe a different color, with the same key code. Because the car manufacturers are missing a few fundamental security concepts, one of which is key space. And they haven't figured out that random numbers are free, and so they're using the same numbers over and over again, right? And we've experienced this a few times. For one brand of manufacturer, we figured out how to manipulate the key so that it will open every car from that manufacturer. Well, how are they going to fix that? There's no system update. It's what they are not understanding is that a car company is now a PC manufacturer. They make a PC on wheels. That's their product. Your television is a PC. Your phone is a PC. Your toaster soon will be a PC. If not, then somebody here should start a company doing that. The point is that adding a PC is a way to add a lot of functionality and capability to another kind of product, right? And everybody's doing it. And when you do that, you inherit a lot of the features, but also the problems that we've been through with PCs. And that's why we have system update now, is we figured out that, oh shit, we can't seem to make this secure and we have to keep updating it. Let's make that easy. So we need to do that in everything. But what it means for you is that you can be prescient. You can look at the future of other industries and other businesses and understand that, oh, computers have not yet impacted that business, but they're gonna. It's true for everything. Gives you a chance to get out ahead. Anybody here use locks like this on your front door? Who here has tried to pick locks? Nobody? Oh man, lock picking's exciting stuff. All right. Well, normally use tools like this, which are kind of tedious. You stick them in there and finick with them, and you kind of need OCD. I'm going to show you the easy way because I don't have the attention span for that. So this is a key that is the right brand for the lock, but it's not cut properly. I've modified it. So I stuck it in there. And all I'm doing is smacking it a few times. There we go. I just picked a lock. It was really, really easy. Any of you guys can do this, which I'm sure you're going to want to do, just, to freak your friends out. This technique's called bump key. You can watch videos of 11-year-old girls on YouTube showing you how to do it. I don't have a lot of time, so I won't describe more. But you can practice on your lock at home. Anybody use these USB thumb drives? Print my Word document for me? They're popular in the States, surely. It's like the new floppy disk. Anyway, mine's kind of like yours, except that while you're printing my Word document, magically and invisibly in the background, it's just making a handy backup of your documents folder, your browser history and cookies, the registry, all those things go in a little invisible folder on here, in case you ever need them. You can come see me. So anybody here ever use credit cards? I don't know what's going on in Romania. In the US, these things are very popular. We give them to teenagers. A few years ago, I got a new credit card in the mail with a letter explaining how it was my new secure credit card, which I thought was exciting because it's not every day I get something in the mail that says it's secure. So it turns out that one of the reasons they think it's secure is because it has this RFID chip in it. And in the States, we're deploying these readers in stores where you don't even have to get your card out of the wallet anymore. You just have to wave your wallet over the reader and you pay. Do they have that here? They do? No? It's just a little bit? Okay, well, maybe you're not getting these secure new credit cards like we are. Anyway, so we looked into it. We bought a bunch of RFID gear on the internet. Anybody have one of these cards? Nobody? Yeah? Got one? Come on up. This will be fun. Come on, bring it up. Come on up. I figured we'd have to crack the crypto system, which we know a thing or two about because we've had to do that before. I had to make this obnoxious cable that you're watching me fumble around with here. Oh, and one of the, okay, so this is chip and pin, which is much smarter and vastly more secure. We don't, okay, all right, we'll steal my own credit card. Thanks. All right, so anybody use Python for their PowerPoint around here? Okay, I bought this reader on eBay for $8. They have them in taxi cabs all over America. They're on the counter at Starbucks. We wrote a little bit of code. This is my American Express card that they sent me, which is secure. And beep. Did you hear the beep? It beeps when you steal credit cards. That's how you know a hacker is coming after your credit card number. It turns out there's no crypto in this thing at all. It's just like broadcasting your credit card number around. And I don't know why they think that's secure. Oh, I just set it down next to another card. Anyway, so you can see my mom calls me Paul. There's my expired American Express card number. I don't really know what the point is. What's interesting is the credit card industry does not have a security problem, right? They have a risk management problem, okay? There's $1 billion a year in credit card fraud. Actually, it's more than that. I don't even know what the number is now. And that's okay, right? When I steal your credit card number and go shopping on victoriassecret.com, what happens is you figure it out looking at your statement. You call your credit card company. They give you the money back. They call Victoria's Secret's bank and say, give us the money back. No problem. They get the money back. Victoria's Secret calls the merchant, says, or the Victoria's Secret's bank would call Victoria's Secret and say, give us the money back. So the merchant loses the product they mailed me. They lose what they got paid for it. They lose the transaction fee. They also lose what's called a chargeback fee, which is a $25 usually fee for every fraudulent transaction, right? All of the risk is pushed onto the merchant. This is really instructive because it means for you guys, when you have what you think is a security problem, you can step back and look at it and decide, well, do I have a security problem or is there something I can do to mitigate my risk, right? And in a lot of cases, you can do that. You're never going to make things totally secure. And if you don't believe me, then we should probably go have lunch and talk about it some more. Ignore that one. Okay, so this is a protocol diagram for SSL. That's the encryption system in your browser that protects your credit card when you send it to victoriassecret.com. Pretty exciting slide. what's going on here is a complex protocol between the client and the server, between the browser and the web server, doing a bunch of crypto stuff, which we won't get into. But the point is, hackers will attack every point in that protocol, right? What happens when I send 2 responses instead of 1? What happens if I send a date from the future? What happens if I send a giant response? What happens if I send a 0 instead of a 1? These are all things I'm going to try and just see what falls in my lap, right? See if I can get it to break. As you guys know, when you're building a product, you're usually worried about making it do what it's supposed to do. You're not really putting a lot of resources into figuring out all the other things people might try to do, and that's why hackers can have so much fun with it. If I can get it to break in one way, maybe I can get it to break in some other way, like a way that gives me your credit card number or something, right? That's what's going on with hacking. That's kind of what SSL looks like to a hacker. This is Anopheles defensi mosquito carrying malaria in Africa. These guys kill about 1 million people a year, half of whom are kids. This is a protocol diagram for malaria. Spends some of its life cycle in a human, some of its life cycle inside of a mosquito. It's complex. There's lots of points in this protocol that I need to attack, and that's what we're doing in our lab, is attacking every point in this protocol, figuring out how do we upset the life cycle of malaria, right? We want to know if there's something simple we can do, or maybe a combination of things. We're trying to come up with new tools. We eradicated malaria from the southwest in the United States. We eradicated it from the southern part of Europe here. We didn't finish the job, and it's still an epidemic in Africa. And so what we're trying to do is come up with new tools. And I need those brains that I described earlier to figure out what's possible, to discover what's possible so that we can make new tools for attacking malaria. The old-fashioned way is spraying DDT, spraying chemicals that just kill everything, right? This is an actual ad from like the 30s or 40s where we're teaching kids to sing about DDT so they'd be happy about it. But yeah, we don't do that anymore. That's part of the reason why we have this problem. So at the Intellectual Ventures Lab, what we do is we invent stuff trying to take on some of the bigger problems that humans have. I have every tool in the world and one of every kind of scientist, and what we do is we work on the same team to try and come up with crazy ideas that maybe are a little futuristic, but might have a possibility of affecting some of the problems that we're working on. One of the ways we cheat is we do a lot of computational modeling, right? This is a 5,000 core cluster we have in the lab. You can rent these by the hour or by the minute online. And we do computational models for the transmission of diseases in Africa, for example. So this is a Monte Carlo simulation where we model the transmission of malaria all over Africa. This is just showing Madagascar, but we have data about everything that can affect the transmission of disease that we can get data on. So rainfall, the climate, travel of humans, everything that's going to affect the transmission of the disease. And we model that over time. And so what we can do is show the cases of malaria over the course of the year. Here you can see Madagascar. In the winter it's not so bad. And then over the course of the year, as it gets hotter, we get more and more activity. This is more cases of malaria, prevalence of malaria. In the winter, it almost all goes away completely. And so you can imagine, oh, what if we could get it to go all the way? And so the point of modeling like this is that we can test our interventions thousands of times in software before we ever do it in the real world. We can sprinkle some DDT there, deploy some bed nets here, and see what happens over time. This is unprecedented capability for humans, and it has drastic effects for all of you going forward. Every one of your businesses will be affected by the computational ability we have. This was too expensive to do 5 or 10 years ago. Now the computational resources are available. We can make models for everything. that are not just simple algorithmic models, like what happens to males 25 to 35 when they use this many condoms in a year. We can make a model for every single individual human on Earth. We can make an ad campaign for them, right? We can predict their behavior as an individual because we're collecting data. That's what your businesses on the web are about. And I feel like a lot of people are missing out on that and doing too simplistic of things when they could be applying computational resources. This is one thing I just threw in because I wanted to show you. I'm almost done here. This is a map of Africa. We don't exclusively work on Africa. This is just something I want to show you today. I think it's probably too difficult for you to see what's going on here. This shows internet deployment in Africa. So basically you run subsea fiber around the continent, right, to give internet to a place like Africa. Well, this shows new cables being deployed. 2010, 2011. These are new bits of fiber coming online, deployed in Africa. If you look at this, what it shows you is greater than an order of magnitude growth in internet available in Africa this year, right? So there's a whole hell of a lot of people on this continent who've been on dial-up or less for the entire history of the web, for your entire life. Most of these people have never been online, and it's been impractical to even imagine getting them online because we didn't have enough bandwidth. We're going from like a terabit for the entire continent to about, I don't know what it is, like 20 terabits for the entire continent this year. It's going to dramatically change that entire population's ability to get online and experience what you have. The economic opportunities that the internet brought you are going there, except with a greater population and greater economy. The possibilities, entrepreneurial possibilities on the web there are going to be vast. I think this is interesting for you because Americans really suck at taking something global and adapting it for other markets and internalizing what's weird and different about every country and every culture. We just build stuff for ourselves and feel like we're done, right? Europeans are not like that. You guys are pretty good at figuring out, how do we make it work a little with all these different countries that we have here and different cultures and the ways things are different. Well, the reason nobody believes they can get anything done in Africa is because that kind of complexity is compounded in a place like Africa. But you guys are ahead of the game. I just think there's possibilities there you should keep an eye on. Last thing I want to show you is an invention we came up with that finds mosquitoes flying around in the sky and shoots them down with laser beams. So here we're tracking mosquitoes. We aim a laser at them and we sample their wing beat frequency. From that we can determine what species it is. This is a mosquito. It's Anopheles defensi. We can determine that it's female. And then we shoot it down with a lethal laser, right? And that's what you can see is going on here. This is not the kind of invention you'd come up with if you were working in the trenches in Africa. What we do in our lab is we take a guy, in this case Bill Gates, whose problem was malaria, and we sit him down and we say, okay, what's your problem? Mosquitoes in Africa, got it. We surround him with a nuclear physicist, a laser expert, a chemist, a computer hacker, and collectively we know the cutting edge of every area in science and technology, and we can come up with crazy ideas like lasers for mosquitoes, right? This is what mosquitoes look like when they're flying. It turns out we have no idea how they fly. It's not Bernoulli effect. They're like swimming in air or something. But since I got this really cool camera that can shoot 1 million frames a second, we started filming mosquitoes. And this is what it looks like when we get them. That guy just got lit up with an ultraviolet laser. He's not coming back. This is deeply satisfying stuff because everyone hates mosquitoes. That guy's wing just got vaporized. He won't be spreading malaria at anyone. And this is a bit of overkill. We hadn't quite tuned the laser yet, so we just vaporized the entire bug. But again, nobody's coming to the rescue of mosquitoes. So the idea is that we put this laser system on a fence post every 100 meters or so around a building or around a village, and it just shoots mosquitoes as they're flying in towards humans to get to get blood for reproduction at nighttime. So that's all I had to show you today. I'm happy to take questions. I'm going to be around for the next couple hours. I'd love to talk to all of you about startups. I started one of the first web development companies in the world, which failed and sucked 15, 20 years ago. But my heart is in it, and I love helping you guys out. So if anyone wants to come chat with me, please spend your time doing that while I'm here. Thanks.
Thank you, Pablos. Thank you, Pablos. Questions, if you have, my colleagues are in the venue. Yeah. I have to underline one thing.
Okay.
You can leave the credit card.
What's that?
You can leave the credit card.
I can leave the credit card. Yeah, no problem. It's
so.
How many do you want?
I already saw your presentation,
sure.
And I think you forgot to mention that you have actually managed to identify the mosquitoes using the frequency of their wings.
Yeah, I've been talking really fast, but yeah, that's right. The wing beat frequency is enough to separate out both different species of mosquitoes, but also the gender. So that's why I said we just shoot the females. And we can use the same system. We're adapting it now to protect crops as well. So we can just let all the harmless bees and butterflies come and do their thing, but we can just shoot the pests. This is important for you guys. Here's why. Moore's law made it possible for us to compute the value of the life of every individual bug before we shoot it. That's vastly different than spraying chemicals that kill everything. Computation is free. Use it. Do something ambitious. Thanks. Yeah.
Hi. I'm just curious how much here.
Yeah, thanks.
I'm just curious, how much does a system like that shoots mosquitoes with lasers cost?
Right.
And how realistic is that? I mean, it's a very cool solution.
Right. Who remembers subscribing to cell phones in the 80s? Or, okay, early 90s? Pretty fucking expensive, right? What happened? Moore's law. Now Africans have cell phones. Everything in our system we bought on eBay. It's consumer electronics. It's the laser from a laser pointer or a Blu-ray player. It's the chip from a PlayStation to do motion detection algorithms. It's the CMOS sensor from a video camera. All that stuff follows Moore's law. So yeah, we spent thousands of dollars in lab gear to build it. It all follows a curve like this as economies of scale go up. So first thing we'll do maybe in a couple years is build backyard bug zappers for Americans. But in a few more years, it'll be cheap enough that we can do it for 20 bucks and send it to Africa. But that's, you gotta internalize that curve. You've got to internalize Moore's law because it affects everything you do so deeply. You can't be stuck in what things cost today because that changes dramatically over time. And it's a fundamental component of the success story behind every one of the businesses you are trying to emulate. Yeah.
I have a question.
There is one more question.
Any other?
Yeah.
Hello. About the mosquitoes again.
Can you raise your hand, please? The one that's talking right now. Yeah. Hello.
Hi. Actually, I've just read about this, and it seems that the Bill and Melinda Gates Foundation actually founded the.
Who am I talking to? I'm sorry, I don't know where. Can you raise your hand?
He's like actually in the back of the room. On the
okay, got it. Okay, thanks. Yeah. Sorry, it just helps. Go ahead.
And they just actually followed up and also founded research into actually creating barriers for mosquitoes with bands of infrared light. And that really sounds like it's quite cheaper and more effective than what you're doing.
Yeah, well,
but what you're doing is really impressive.
Yeah, thanks.
I was just wondering if your labs did that.
Yeah, so what Bill is doing, and all of our, I only talked a little bit about our projects because it's not the point here. We mostly work on other commercial inventions. The malaria work we do for Bill, and he directs that himself and hangs out at the lab with us. But he also, what's great is he's also funding projects all over the world, and other people are working on all kinds of things, not just us. And so he's got a great, I think, perspective on how to achieve this, which is just try and get all these projects going. I haven't heard of the one you're talking about. we don't think this is the solution to malaria. It's just one more tool in the arsenal, one more weapon we can use, and we're going to need a combination of things. But that being said, I believe, as does Bill, that we can eradicate malaria once and for all in our lifetime. And it's totally worth doing. It's low-hanging fruit. It's embarrassing that humans haven't done it already. So we're going to get it done.
How many guys have worked on these inventions, and how many guys do you have on the team?
We started the lab about 5 years ago. It was started by Nathan Myhrvold, who was the first CTO at Microsoft. And at this point, we have about 100 people working in the lab, which is pretty fast growth considering. And we have, we run 20 or 30 projects at a time, and a lot of them they're just all over the map. We've invented a way to suppress hurricanes. I worked on a brain surgery tool. I tried to cure cancer, which didn't work. We have a malaria diagnostic that's going great. We have invented a new type of nuclear reactor that runs on nuclear waste. So it's a pretty large-scale invention lab. Does that answer your question?